So now we're going to have a look at how we can use our inverse normal calculation to help us to find the value of the mean or the standard deviation of a distribution if we are missing one of them. Now this comes from how we used to calculate probabilities using the normal distribution. So as I explained at the end of the previous video, there is a standard normal distribution which has a mean of 0 and a standard deviation of 1. And we usually label this as Z. So we have Z follows the normal distribution with a mean of 0 and a standard deviation of 1. Now, before we could use the graphical calculator to help us to find probabilities, we used to have to use tables to do this. And how this would work is that we would have to use a standardizing formula to change our normal distribution into a normal distribution which fit our standard normal distribution. So if, let's say, we had another distribution here, which was still, can't go quite high enough for making it so that the areas are proportional. So remember that both of these areas should be 1. That should go up higher. I've just run out of space at the top of my page here. And what it is that in order to transform our purple curve onto our red curve, we would have to use a standardizing formula. So if here we have x squiggle n mu sigma squared, we can transform our purple graph onto our red graph by using x minus mu over sigma. So x minus the mean all divided by the standard deviation. And this is what we used to have to use all the time when we were trying to find the probability of a normal distribution. Now, luckily, we can use our calculator to do this instead. And we're actually only going to use this formula when we are trying to find the mean and or the standard deviation. And it works by the fact that if we were to transform the purple graph onto the red graph, then we'd be looking for the same probability given by the red graph. So that's just a little bit of information about why this works. We are going to simplify it though, and we're going to perform 3 steps, and we're going to perform the same 3 steps every time. So our step 1 is always going to be to pretend it's following the standard normal distribution. So we have a mean of 0 and a standard deviation of 1. Our step 2 is always going to be to standardise, which is using our x minus mu over sigma formula, which I just wrote here. And then our third step is going to be to equate and solve. Now this is always going to follow the same 3 steps. Even when we go on to finding both of them at the same time, we will still end up following the same 3 steps. So in our example, we have a normal distribution has a standard deviation of 6. So we can write down this distribution. So we have x follows the normal distribution. We don't know what the mean is, so I'm just going to leave that as mu. And we have a standard deviation of 6. So we'll have 6 squared here. Now, sometimes this probability might be given in words, so where 38% of the data exceeds 37, okay, that'd be a way that this could be written in words. But for now, we've got P of x being greater than 37 is 0.38, and we're trying to find the mean. So as I said, the first step is always going to be pretend that we have the standard normal distribution. So to do this, we go into dist, norm, inverse normal. Now, if we were to draw this, we would have our tail going to the right. So tail is going to the right. The area is still going to remain the same from this part here. So 0.38. However, because we're pretending it's the standard normal, we're going to put our standard deviation as 1 and our mean as 0. And that gives us 0.30548078. I am going to do a further calculation with this, so I'm not going to round it at this point. I'm going to keep the whole number. So then step 2 is to standardise. So using our x minus mu over sigma. Now the x value we get from the information that we were given here, that's 37, minus the mean, which we don't know, divided by the standard deviation, which is 6. And then the third step is to equate and solve. So we are putting our answer to part 1, our 0.3054878, equal to our answer to part 2, which is 37 minus mu over 6. And then we're going to put this into the solver function in our calculator. So remember, that's back. If we go to menu, it's equation, solver, and then we can type it in here. So we've got 0.30548078 equals, which is shift and then the decimal point, fraction, 37 minus mu, and for the mu we're going to use the x theta t button here, divided by 6. Just double check that you've typed everything in correctly. Remember that you have to click xe twice for this function to work, and that gives us a mean of 35.2 to 3 significant figures, and that's it. So let's try again. So this time we have, we know what the mean is, so x squiggle n, we know that the mean is 51, and we're trying to find the standard deviation this time. So step 1, we're pretending it's the standard normal. So go back into the statistics function in your calculator, dist, norm, inverse normal. This time our tail would be going to the left. Our area would be 0.68 from here. The standard deviation is 1 and the mean is 0 because we're pretending it's the standard normal, which gives us 0.46769879. Remember, don't round at this point. Step 2 is to standardise using x minus mu over sigma. Remember that the x comes from this part as well. So it's going to be 57 minus mu, which is 51, divided by sigma. We don't know what that is, so we're just going to leave that as sigma. And then 3 is to equate and solve. So we're setting our answer to part A, our 0.46769,879, equal to our answer from part 2, which is 57 minus 51 divided by sigma. And then we're going to put that into the solver part. So equation, solver, 0.46769,879 equals, which is shift and then the decimal point, fraction, 57 minus 51 divided by sigma. We don't know what that is, so that's what we're going to use our x theta t button for. Again, quickly make sure that you've typed everything in correctly, and remember that you have to click xe twice. So then that gives us a standard deviation of 12.8 to 3 significant figures. So I'd like you to pause the video now and give the 2 now you try questions a go. Okay, so hopefully you paused the video and you gave the 2 now you try questions a go. So for the first one, when we pretend it's the standard normal, we have our tail going to the right. Oops, we have our tail going to the right. We have an area of 0.59. Standard deviation is 1, mean is 0. And just be careful. If I go back into this function, you can see the second answer, but you need to be careful because the minus sign can be quite hard to see. We can see it there, minus, but a lot of people miss it, okay? That's for the next one, but the other one is obviously a negative as well. So just always make sure that you are double checking, does it have a negative sign when you do these? To standardise, we have 4.5 from this, again, this part here, minus mu, because we don't know what that is, divided by the standard deviation, which is 0.2. Step 3, equate and solve. Our answer to part 1 equal to our answer to part 2. Popping that in solver gives us 4.55 for the mean to 3 significant figures. Similarly for the second one, pretend it's the standard normal. So this time our tail is going to the right. Our area is 0.68. Standard deviation is 1, mean is 0. We get minus 0.4676988. Remember, don't round in step 1. Step 2, standardise. X minus mu over sigma gives us 36 minus 38 divided by sigma, because we don't know what that is. We'll leave that as sigma. And 3, equate and solve, setting our answer to part 1 equal to our answer to part 2. And that gives us 4.28 as our standard deviation. Now, for the first one, you can't use this as a check, but for the second one, because we're trying to find the standard deviation, we must end up with a positive answer. If you had read this wrong and read it as a positive and missed the minus sign on our minus 0.4676988, then you would end up with a negative standard deviation, and you can't have a negative standard deviation. However, you can have a negative mean, okay? So that's just an important point. So cannot have negative standard deviation. Okay? However, you can have a negative mean. So if you end up with a negative, if you're trying to find the standard deviation and it ends up being negative, then you have done something wrong. You can't use that as a check with the mean, but you can if you're trying to find the standard deviation. So that's how you find the mean or the standard deviation. We're now going to have a look at how you find, oops, sorry, it's going to head 2 pages instead of 1. We're going to find how we find both of them, and this ends up using simultaneous equations now. We are still going to be following the same 3 steps. So we're still going to be pretending, then we're going to be standardising, then we're going to be using equate and solve. However, that's going to end up giving us 2 simultaneous equations. We always rearrange these in the same way. So once you get used to how they are being rearranged, it becomes really simple as to how you put it in your calculator. So we have a vending machine discharges soft drinks, a total of 5%. So I'm just going to split the top of my page in 2, and I'm going to do the working for one bit here and the working for the other bit here. When you're having to answer one of these, where you're trying to find both the mean and the standard deviation, you will be given 2 bits of information about the distribution. So here we have a total of 5% of the discharges have a volume more than 475 cubic centimetres. So we can write that in terms of a probability. So the probability that X is more than 475 is 0.05. So that's writing this part here. 5% of discharges have a volume of more than 475 centimetres cubed. So now we're going to try and write the second bit in the same probability language. So while 1% of the volume is less than 460 centimetres cubed. So the probability that X is less than 460 centimetres cubed is 0.01. So we're going to have step 1 for both of these, which is both going to be that we're pretending it's the standard normal. For this one, our tail is going to the right and our area is 0.05. Which gives us 1 1.644853363. Again, be careful. There is no negative sign this time, so that's fine. Then for the other one, our tail this time is going to the left and our area is 0.01. So our tail is going to the left, our area is 0.01. And we can see there that we have a negative, so this time it's minus 2.3263479. Step 2 is to standardise, so we're using our x minus mu over sigma. So our x for this one here is 475 minus mu divided by sigma. We don't know what those are. And again on this side, x minus mu over sigma. This time our x is 460 and we still don't know what mu or sigma is. So for 3, we're using equate and solve. So we're going to have 1.6448533 equals 475 minus mu over sigma. And like I said, we're always going to rearrange these in the same way. So we're always going to times by the sigma. So that's going to give us 1.6448533 sigma equals 475 minus mu. And then we're always going to add on the mu. So that's going to give us 1.6448533 sigma plus mu equals 475. So we're going to do a similar rearrangement on this side here. So for 3, we're equating and solving. So minus 2.3263479 equals 460 minus mu over sigma. And as I said before, we're going to times through by our sigma. So minus 2.3263479 sigma equals 460 minus mu. Then we're going to add on our mu. So we're going to have minus 2.3263479 sigma plus mu equals 460. And these are the two equations that we are now going to put into our calculator. This one here and this one here. So if we go back to our menu, we're going to go down to equation. And this time we're going to go into simul. How many unknowns do we have? Well, we don't know what sigma is and we don't know what mu is. So we have 2 unknowns. And you can see at the top here the format that we need it to be in so that we can put it into our calculator. So both of them need to be some value of one of the things we don't know, plus or minus some value of the other thing that we don't know, equals some number. And both of these have been rearranged in that way. So rearranging it in this way, timesing through by the sigma and adding on the mu, always make sure that you've got them in the right format to put into this part of your calculator. Now when you're putting these into your calculator, you're only writing the coefficient of each of the values. So here, where we've got 1.6448533 sigma, we're just going to type in the 1.6448533. That's it. That's all we write in. We don't put the sigma bit in. We just put that bit in. 1.6448533. Then for the next bit, we've only got a mu. But if you think back to what you would have learnt at GCSE, if anything's ever written like that, it means you've got one lot of it. So we put in a 1 for that bit. Equals, and then we just put that number that's on the other side, so 475. Now we do the same for the other equation that we have, so it's going to be minus 2.3 to 63479. Just double checking that I've typed that in correctly. We have 1 mu equals 460. And just as we do with solver, we have to click XE again, and we come up with those two values. Now, because in both of these equations, our sigma is the first symbol that we have, the first answer at the top here is our sigma. So sigma equals 3.78 to 3 significant figures. And our mean is going to be 469 to 3 significant figures. So I'd now like you to pause the video and give the now you try question in the same way. Remember, when you are rearranging, you always times by the sigma and add on the mu. Just so that you can double check that you're working with the correct equations. From given that 10% of the seedlings are taller than 15, we should end up with this part here. Probability of x being more than 15 is 0.1. And from the 5% are shorter than 4 centimetres, we should have p of x being less than 4 is 0.05. That's just to make sure that you are using the right equations, to do your 3 steps with. So hopefully you paused the video and gave the rest of the now you try question a go. So for our step 1, for our x is more than 15 equals 0.1. So in our inverse normal, our tail is going, our tail is going to the right. Our area is 0.1, which gives us 1.28155,157. For the other one, our tail is going to the left. Our area is 0.05, which gives us minus 1.6448536. Then when we're using our x minus mu over sigma, for the first one we have 15 minus mu over sigma. For the second one we have 4 minus mu over sigma. And then for the third step, we're equating and solving. So we have our 1.28155,157 equals 15 minus mu divided by sigma, times through by the sigma, add on the mu, and we end up with 1.28155,157 sigma plus mu equals 15. Then on the other side, we've got minus 1.6448536 equals 4 minus mu over sigma. Again, times through by the sigma, add on the mu, which gives us minus 1.6448536 sigma plus mu equals 4. And when we put that into our symbol, remember that we're only writing in the numbers before the symbol. So 1.28155,157, 1, 15, and then minus 1.6448536, 1, 4. And we end up with these two values here. Because our sigma is first in both of our equations, our sigma is the first answer here, and the mu is the second answer. And again, remember that your standard deviation can never be negative. So if you've ended up with a negative standard deviation, you've done something wrong. A way that you can check that your mean is realistic is it roughly around the values that you've been given for your x's? So here we've got 10.2. None of our probabilities or the standard deviation are massive, which means that yes, 10.2 seems like it's a reasonable solution. If I ended up with 102 as my answer, then I would probably think I've done something wrong, because 102 is vastly different from 15 and 4, and I don't have a gigantic standard deviation. And the section that we're going to come on to next, which is having a look at the properties of the normal distribution, will help you to get used to the fact that that wouldn't happen. So thank you very much for listening.